Okay, now we've got a swimming pool question where we also have to use our skills in volume and also our skills in surface area. The first question is, how many litres of water does the pool hold? How many litres of water? Well, if we're going to be able to work out the number of litres of water, we first need to be able to calculate the number of cubic metres of water, because we've only been given measurements here in metres. So in order to work out the number of cubic metres of water, we use the formula for volume is the length times the breadth times the height, where I should really define all my terms here. V equals volume, L equals length, B equals breadth, and H equals height. So important when we're doing maths that we actually define, here's an equation, here's the formula that I'm going to use to calculate the volume, and here are the terms that I've defined that I'm going to use in this formula. Okay, now we don't have to write volume all the time, we just write V, and we know that that means volume. So the volume is 12 metres times 6 metres times 2 metres. Well, 12 sixes are 72. 12 times 6 is 72. 72 times 2 is 144. Okay, then we also have the metre terms. Metre multiplied by metre is that we've got 3 metres consecutively multiplied, so metres cubed. Metre times metre times metre is the same as metres cubed. So we now have that the volume of water in the pool is 144 metres cubed. But that wasn't the question. The question is how many litres. And the thing that we need to remember here is our volume conversion units. If we were going to go from metres to decimeters in length, we would multiply by 10. But if we were going to go from metres cubed to decimeters cubed, we would have to multiply by 10 cubed, which would be the same as multiplying by 1,000. But 1 decimeter cubed actually equals 1 litre. A litre of milk is exactly the same as 1 decimeter cubed. So if we were going to convert this volume into litres, we'd have to take our 144 metres cubed, multiply them by 1,000 to change it into decimeters cubed, which is the same as the litres. So we'd get 144,000 litres of water in our pool if we were going to fill it from absolutely rock bottom. Then we have a question B, and it's right, okay, how long is it going to take us to fill the pool if we fill at a rate of 50 litres per minute? Well, we have 144,000 litres. If we divide that by 50 litres per minute. So the way that we're going to get time, if we look at our formula here that we're going to use, we're going to take the volume of the pool divided by the filling rate. Okay? And it can be thought of as being a little bit similar to our speed diagram, where we have that the filling speed or the velocity is distance over time. Instead of that, what we would get is that the filling rate, if we would call that R, the rate of fill, would be the same as volume of the pool divided by the time. So it would be a slightly different triangle. But here we have the volume of the pool divided by the rate, and that will give us our answer in minutes. Why do we get the answer in minutes? Well, we have litres divided by litre per minute. Litre divided by litre gets rid of the volume unit, and we have per minute, we have 1 divided by 1 per minute. We have like what we call a double divide here. When we have two divides under one another, the number that was under the second division line sort of goes to the top. So it gives us our answer in minutes. Okay. Then what is 144,000 divided by 50? Let's cancel the zeros. Then we get 5s into 14, go 2 times, 4 left over. 5s into 44, 5s 40, 5 eighths are 40, and we had 44, so that will give us 4 left over. 5s into 40 go 8 again, and then 5s into 0 goes 0. So that gives us 2,880 minutes to fill our pool. Are we allowed to answer like that? Absolutely not, because we actually don't have very much idea of how much 2,880 minutes is. We have to convert that number into hours by dividing by 60. So let's do that. 2,880 divided by 60. The zeros cancel. 6s into 28, 6 4s are 24. We had 28, so there's 4 left over. 6s into 48, 6 8s are 48. So we get that that is 48 hours. And look, isn't that convenient? It actually works out that it would take us 2 whole days of filling the pool to get the pool filled with water. So that's finished our volume and flow rate. Now we have another question, so I'm just going to make a little bit of space here. Let's go and take all of this, rub all of this data away, because we don't need it anymore. Because the next thing was, what do we do if we would like to tile? The liner of this swimming pool is broken, so we would like to tile the swimming pool with tiles instead. And how do we do that? Well, in order to look at the tiles, we need to think of how many surfaces would we have to tile. The first surface that we would have to tile, and here we need area formula, would be the bottom of the pool. Let's look at the bottom area. It would be the length of the pool multiplied by the breadth of the pool, which I don't have to write in words because I've already defined here what length and breadth are. So the area of the bottom, let's call it AB here. So we've defined what the area of the bottom is. The area of the bottom will, of the pool will be the length times the breadth, which will be 12 times 6. 12 6s, 72. What are the units? Meters times meters, meters squared. So the area of the bottom will take 72 square meters of tiles. Then we have two sides. We have a side here, short side, and a side here. So we have two short sides. So let's work out the area of the sides, and we'll call that AS. The area of the sides. That will equal the breadth multiplied by the height, multiplied by 2, because we have 2 of them. The breadth is 6, and the height is 2, and we multiply by 2 because we have 2 of them. 6 4s are 24. So the area of the short sides of the pool will be 24, and our units will be meter times meter, meter squared. Now we have the front and the back sides of the pool. So we now have to think about tiling the front here and the back side here. So the area of the front and the back, area, front and back, and the formula for that will be the length multiplied by the height multiplied by 2, because we have the front and the back, which will give us The length is 12, the height is 2, and we've got 2 of them, so we multiply by another 2. 12 fours are 48 meters squared. So we now know the area of all the different sides, the bottom. Of course, there's no top to our swimming pool, otherwise we wouldn't be able to dive in and swim. So now we have the different areas, and now we can just add those together. So to get the total area of surfaces that we would need to tile, we'd need to add 72 plus 24 plus 48. That will give us 14, which I can't write because there's not enough space down there. Let's do it over here. So we'll get 14 here, and then 7 plus 4, 11, plus 1, 12, plus 2, 13, 14. So 144 meters squared. So the total surface area of tiles, total area to be tiled, equals 144 square meters of pool that need tiling. So here you can really see the difference between what volume is, which is the amount of water that you fill the pool with, and surface area, which you can consider how much area would I have to count to tile the surface of the pool. But we're not quite finished there, because now it says how much would it cost you then to tile this pool if 1 square meter of tiles cost 150 kronas. How expensive would it be to tile this pool if 1 square meter of the tiles cost 150? Well, then we take so the cost will end up being the area of pool that we've got to tile multiplied by the cost of 1 square meter. We have to tile 144, and every square meter is going to cost us 150 kronas, and we have 144 square meters. So we can actually cheat a little bit here and just use our calculators. 144 times 150. We could do it and set it up nicely as a proper long multiplication, but just to save time here, I'm going to do that on my calculator. The final cost that we end up with, and I'm running out of space here, so I'm going to put it up here in this corner. If we multiply 144 by 150, our final cost for the tiles is going to end up being 21,600 Swedish krona. Okay, so if we were going to tile this pool, that would be 21,600 kronas, which is about 2,000 euros, about, yeah, 2,000 pounds. So quite a lot of money to tile our pool. So there was lots of different aspects involved in solving this little question. Okay.